Have you ever looked at a piece of gold jewelry, or maybe even the gold-plated connector on a cable, and wondered where it all came from? The story of gold is more epic than any blockbuster movie. It's a tale that begins not on Earth, but in the fiery heart of a dying star. Imagine a star, many times more massive than our sun, reaching the end of its life. In its final, cataclysmic moments, it collapses and then explodes in a brilliant flash of light we call a supernova. The energy released is so immense, so powerful, that it forges new elements in a process called nucleosynthesis. For a few brief, spectacular seconds, protons and neutrons are slammed together, creating everything from iron to uranium. And yes, our star of the show, gold. These freshly minted gold atoms, along with other heavy elements, are then blasted out into the cosmos, seeding the interstellar medium. Fast forward a few billion years, as our solar system began to form from a swirling cloud of this very stardust and gas. These heavy elements, including gold, were incorporated into the mix. Early Earth was a molten ball, and heavier materials like iron and gold sank towards the center, forming the planet's core. So, the gold we find near the surface today wasn't originally part of Earth's crust. It's actually a gift from the heavens, delivered much later. For hundreds of millions of years after its formation, Earth was relentlessly bombarded by asteroids and comets remnants from the solar system's construction phase. This period, known as the Late Heavy Bombardment, was a cosmic delivery service. These celestial bodies, carrying their own payload of gold forged in distant supernova, slammed into our planet. Upon impact, they deposited their precious cargo onto the surface. Over geological time, volcanic activity and the movement of tectonic plates have churned this gold, concentrating it into the veins and deposits we mine today. So, every nugget, every flake of gold has traveled across space and time to get here. It's literally stardust. But gold isn't just beautiful. It's also incredibly useful. Its unique properties make it one of the most versatile and valuable materials in science and technology. Why? Well, for starters, gold is an excellent conductor of electricity. It allows electrical current to pass through it with very little resistance, which is crucial for efficient electronics. But copper is a great conductor too, and it's a lot cheaper. So what makes gold so special? The secret lies in its other key property. Gold does not corrode or tarnish. Unlike other metals that react with oxygen and moisture in the air, think of how silver tarnishes or iron rusts. Gold is incredibly stable. It's a noble metal, meaning it resists chemical reactions. This combination of high conductivity and resistance to corrosion makes it the perfect material for critical electronic components. From the smartphone in your pocket to the complex systems that guide spacecraft, you'll find gold. It's used to plate connectors, switches, and relay contacts, ensuring a reliable, long-lasting connection that won't fail due to a little bit of rust. Let's take a journey into orbit. Look at the James Webb Space Telescope, our eye on the universe. It's massive. Honeycomb-like primary mirror is coated with a microscopically thin layer of pure gold. This isn't just for looks. Gold is exceptionally good at reflecting infrared light, which is the wavelength that allows the telescope to see through cosmic dust clouds and peer back to the dawn of time, observing the first stars and galaxies. Without its golden mirror, the James Webb wouldn't be able to capture those breathtaking images that are rewriting our understanding of the cosmos. The very element created in the death of old stars is now helping us witness the birth of new ones. It's a beautiful cosmic symmetry. Back on Earth, the influence of gold extends deep into the heart of modern medicine. In the field of biotechnology and diagnostics, tiny nanoparticles of gold are revolutionizing how we detect and treat diseases. Because gold is non-toxic and biocompatible, it can be safely introduced into the human body. These gold nanoparticles can be engineered to bind to specific molecules, like proteins or DNA sequences associated with a particular illness. For example, many rapid diagnostic tests, including some home pregnancy tests and COVID-19 tests, use gold nanoparticles. When the target molecule is present in a sample, it binds to the gold particles, causing them to clump together and change color, giving you that clear positive or negative result. It's a fast, reliable, and highly sensitive method of detection, all thanks to the unique optical properties of nanometer-sized gold. But it doesn't stop there. Researchers are exploring the use of gold nanoparticles in cancer therapy, in a technique called photothermal therapy. These tiny particles are designed to accumulate in tumor cells. When a near-infrared laser is shined on the area, the gold particles absorb the light energy and heat up, destroying the surrounding cancer cells while leaving healthy tissue unharmed. It's a targeted, precise approach that could one day offer a powerful alternative to traditional treatments. And finally, we come to the brain of all our modern devices, the computer chip. Inside every microprocessor and memory chip, there are billions of microscopic transistors connected by an intricate web of wiring. For the highest performance chips, where speed and reliability are paramount, you'll often find gold. While copper is more common for the bulk of the wiring, gold is used for the critical bond wires that connect the silicon chip itself to the external pins of its package. These wires are incredibly fine, sometimes thinner than a human hair, but they carry vital signals. Using gold ensures that these connections remain perfect over the lifetime of the device, free from corrosion that could cause a catastrophic failure. From the powerful servers that run the internet to the processors and cutting-edge scientific instruments and the gaming PC on your desk, gold is there, silently ensuring that data flows flawlessly at the speed of light. It's the unsung hero working deep inside the digital world we've built. So, the next time you see gold, remember, it's an incredible journey. It's a story written in the stars, delivered by asteroids, and woven into the very fabric of our future. From the explosive death of a star to the life-saving technology in a hospital and the digital universe in our hands. Gold is a timeless element that connects the cosmos to our modern world in the most profound ways. Thank you so much for joining me on this journey through space and time. If you enjoyed this exploration and want to learn more about the amazing science behind our world, don't forget to like this video and subscribe to the channel. Let me know in the comments what other cosmic stories you'd like to uncover. Until next time, stay curious.